Well, hi everybody. This is Lex. I'm joined with Toon Vanhoutte. He's CTO at Vanhoutte in Belgium. Today we're going to talk about generative AI. That's an area where Toon is currently focusing on work-related, I must say, not just as a hobby, but also in your job. You come across it quite often, right?
Yes, indeed. Quite a lot of projects currently going on.
Yeah. That's great. Yeah. Well, Toon has been around for quite some years in the integration space. He's an MVP also for quite some years. You can see it on the top shelf of his closet there. Can't be missed. And he's also a frequent speaker at our Integrate conference in London, and also this year as well. He will be one of our respected speakers, and your session is about integration and mistakes, right? That you come across and you also see being made by other people.
Yeah, I want people to learn from mistakes that other people make, so we don't trap in the same mistakes again. So.
Exactly. Yeah, there are also gifts, right? A mistake that you make, you always learn from it and improve.
Definitely, yeah. Yes,
so that's a great thing. Yeah. Okay. Well, I would just say let's go ahead. Let's start with the actual presentation.
Okay, perfect.
To introduce.
Thanks for the introduction, Lex. So indeed, this session is about an introduction in generative AI. It's a broad area, so my focus will be here in retrieval-augmented generation. That's a kind of a subset of the solutions that we built, because I see that that request is maybe the most popular one amongst our customers. So I've been introduced already. Maybe it's good to know I'm a dad of two fantastic kids and a big cycling fan. But if you live in Belgium, it's difficult not to be a cycling fan. That's But for the rest, indeed, CTO at Vanhoutte and Azure MVP. Background from the integration community, but always looking for new areas where I can explore new solutions that we can build. And maybe also one of the goals of this session is to show if you are an integration developer, Gen AI is not such a big change to make. So that's also good. So before we dive into the whole retrieval augmented generation concept, I want to start a little bit with the early beginnings. It's all about large language models. But first, large language models are a subset of generative AI, and it's actually about generating outputs based on prompts, prompts on inputs that people or machines give. And that could be in the form of text, images, audio, and video. So it's not only limited anymore to text, but you have all these kinds of in and outputs that are becoming available right now. The focus of my session here is on large language models. So that's more about the human-like text. It's about generative AI models that can understand and generate human-like language. And that's, of course, only possible because they are trained on massive amounts of data. We use it, of course. People know the chat GPT solutions, of course, where content gets generated, where you can ask questions and get answers back. But actually, in organizations, you can use it for a lot more than that. You can use it for classification, for example. So if you get a question on the support desk, you can immediately classify what is this question about. And based on that classification, the chatbot could ask some additional questions. You can also do a lot of automation and also data extraction. I'm just thinking there about OCR. And so in the past, invoices, orders, they were automatically written with OCR, but then you really needed to show, okay, the order number is always at that location and the customer name is at that location. Nowadays, with those GPT vision models, you can actually just send the invoice and it will extract the customer name, it will extract the invoice number and so on. So that's pretty cool. Maybe a good thing, Lex, there. We had a customer who had a Chinese invoice and they just tested it and it also works.
So
these large language models, they are typically multi-language, so they are language agnostic. So if it works in one language, it typically works for another one. So
Yeah, it's just so smart, right? I mean, well, yeah, we've already when GPT 3.5 was released, there were already so many capabilities and possibilities just with text.
Yeah,
But indeed, with the GPT 4.0, it has been so much more powerful, and even not just the GPT 4.0, but also with that integration with well, actually not integration with Copilot actually. How Microsoft is adopting it, it's just so useful in your day-to-day work as well already. And as
yeah,
you go,
indeed.
yeah,
And
as you go,
it will only get better. So that's we are
exactly
actually only at the early stage, so it will only get better.
correct.
For me personally, I'm a big fan of the Microsoft 365 Copilots. But the one who even changed my life even more is the GitHub Copilots. If you start programming, it really does a lot for you, because it's if you have a well-structured code base, it knows how you work. So it typically suggests already a lot of
Yeah,
code for you. So that's really a big advantage also over there.
correct. Yeah, correct. Yeah, yeah. Last week we had a session with Martin Abbott,
Yeah.
and he also did a demo on GitHub Copilot, and it's just so powerful, and it really improves your what is it productivity, right, as a developer.
Yeah, definitely.
Yeah, and
Of course,
at
it
the same,
always remains an assistant. You are in the end responsible, of course, for the end result and the end quality. But it makes sure if you know what you're doing that you can program a lot faster. That's it.
correct.
And you can then focus, of course, on points that needs more your attention, and that's security, that's code quality, these kind of things.
Yeah,
But the more boring stuff can be improved
yeah,
and can be
yeah.
more efficient. So that's good.
Yeah. The boilerplate stuff, all that is just generated.
Yeah, indeed, yes.
Yeah,
All right, maybe let's have a smaller look in how such a large language model works. It's actually based on chat completion. So chat completion, you ask a question and the large language model will answer on that. So there are a few concepts that you need to understand. The first one is the system prompt. With that prompt, that's just a text that you give to the large language model where you say how the large language model should behave, what its task is. So here I say, you are a helpful assistant and please talk like a pirate. And of course, in the system prompt, you can ask whatever you want. You could ask also, say, for example, to the large language model, don't base yourself on what you already know. Make your statements only based on what you receive in the prompts. Those are things that you can put in such a system prompt. Then, of course, you have the user message. The user message is the message that comes from the user who typically says, okay, a question, who asks a question to the large language model. So those two together, that's your input. That gets sent to the large language model. And then, of course, the large language model will generate an output for you. And the messages that are being generated by the large language model, that's what they call assistant messages. And the assistant, the large language model. So those are a few concepts that you definitely need to know. The good thing is also to know is that when you send your input to the large language model, you can provide a temperature. And that's actually a value between 0 and 1. 1 means, you can go bananas and you can be very creative as a large language model. 0 means, you need to be very strict. Don't start inventing stuff. Only base it on what you know. So, of course, for professional use cases, most professional use cases, unless we are in brainstorming and stuff, the temperature is typically between 0.1. Typically, that's the tipping point that we dare take. Input output for us, those are words and sentences, but actually large language models, they don't think in words and sentences, they think in tokens. A token is there, a basic unit of language for large language models. And in English, if you take the English language, which is of course very popular, you see that in English words, one token is 3/4 of a word. I see here, I made here an example on the right side where you see at the top the sentences, and then you see how it maps to tokens. So smaller words are typically just mapped to one token, but larger words sometimes get just split in multiple assets.
yeah,
And those tokens are very important to understand because they are typically limited per model. Some models can process a lot of tokens, so a lot of text. Other models are rather limited on that. And in many cases, you also need to pay for your tokens. And so the more data gets processed by your large language model, the more you will have to pay. And so that's important. Of course, you want to control that a little bit. You want to control a little bit how much you will spend. So that's why you have also an additional input parameter that you can give, and that's the max tokens parameter. To that, by providing that parameter, you can say how much tokens the large language model can consume. If you say, for example, the max tokens is 500, and you have an input already of 200 tokens, then the large language model still has 300 tokens to give an answer. And that's, of course, good, because in that way you control a little bit the length of the answer that the large language model will generate. And of course, you can also give instructions in your user or in your system prompt. You can always say, please answer in 1 sentence, please answer in 200 words and something like that. And then the large language model will take it into account.
Yeah, so indeed, so for the free tiers like GPT 3.5 is no issue without subscription, but if you would go for a subscription model, there's still that limitation in the number of tokens that you can use probably per month, right?
Yeah, indeed. And also per minute. So in Azure, you currently see a little bit of a problem. The AI services are very popular, but the demand is higher than the number of services that they have. So you get throttled. You get throttled by the tokens that you consume. So what do we see if you have very intensive projects where you need a lot of requests to large language models? You need to even start load balancing between different regions to make sure that you get not throttled. So that's just because of the market demand is currently too high for the resources available in Azure.
Yeah. That's only becoming more and more, right? I mean, you see the models improving over time, so there will be also more demand because there are even richer capabilities.
Yeah, indeed. And this brings us actually to the next slide here already. I say models improving. Yeah, it's constantly changing. I guess this slide is already outdated again.
Correct.
But here you see there are a lot of models with a lot of versions. Some are in preview, some are already live. But the important thing is, how do you choose the right model? And one of the important assets to make that choice is, of course, the tokens that it can process. And you see the earlier models, they were limited in the number of tokens they could process. But now you see the GPT Turbo for Turbo models. They can, for example, already process 128,000 of tokens as an input. And that's already quite a lot of data that you can send to your large language model. There are also other facets if you need to choose the right model. The price, of course, and the price is, of course, an important one, and also the performance. For example, GPT 3.5 Turbo is very fast, but of course, it's a little bit less capable in reasoning. GPT-4 is a little bit slower, but it can reason a lot. So it's more, let's say, smart. It can make more logical decisions based on data. So it's very difficult, of course, to make the right choice. And sometimes you need to compare 2 or 3 models and see, what gives the best results.
Here, indeed, you mentioned that in April 23, that was the last release. Actually, of course, this very week, we have seen the release, not yet public, but at least the announcement of GPT 4.0. I'm sure you have seen it yourself as well. And that was really overwhelming because it was already possible to speak to GPT 4. 4, right? It was, but there was a latency of a couple of seconds. But now you can have much more natural conversations with GPT 4.0, and there's even emotion in the tone how GPT responds, and it can recognize phones. Well, it can recognize something on a table when you're sharing your screen, or when you're using webcam, that kind of stuff. So that has been added. What's your take on GPT 4.0?
Yeah, it's just, I think, a natural evolution, of course. First of all, it's a lot faster, and it's also 50% cheaper. So that's of course, the models that are getting optimized. So that's an evolution that we definitely will see. The models will become faster, and also they will be able to handle more and more tokens. That's one evolution. Another evolution is that you see actually we had GPT-4 only capable of handling text. Then we had GPT-4 with vision. We have here this one at the bottom. Was already able to deal with text and also with images. So you could upload an image and then ask a question in text, of course. What do you see? Or how big is this triangle? Or can you extract some data from this image? That works perfectly. Now we take it to the next step, and it's really multimodal. So it's not only text, it's not only images. We also talk about audio, and also video will coming soon. In Azure, only the text and images are currently in very limited preview. I tried it yesterday in the sofa, but of course it will take a few weeks, I guess, before everything can be tested. But I'm really looking forward to it because it opens a lot of new scenarios.
Yeah, exactly. Yeah. There's also what the O stands for, right? It stands for omni. So indeed, it can take input from multiple different sources.
Yeah, indeed, yes.
Yeah, there was a really good case in the website, or actually during the announcement, I believe it was, how GPT-4o can also help students maybe with solving math problems with homework support, and really like supporting the students how to approach, and really letting the student think about what is what and what would be the next step. So not just providing the answer, but really an answer response and triggering the student to learn and understand what the problem is about. So really
it's cool to say because I have a 7-year-old kid here, so he has a lot of small, simple mathematical exercises that he needs to do. And actually, from the moment the GPT-4o will be completely in preview, and also API access will be available, I have the intention to create a Power App with some mathematic games and completely audio based. So I'm looking forward already to give it a try and to see what comes out of it.
Yeah. So many opportunities you can think of. Really overwhelming.
All right, maybe a very small demo on how you can consume actually Azure OpenAI. So if you create an Azure OpenAI service, what you have is actually you just get an URL. You need to deploy a model. In this case, I just took a GPT 3.5 Turbo, and you just call the chat completion API. You authenticate with Azure AD or with an API key. And this is actually how your body looks like. So you send a system message. That's a system prompt where you say, okay, you are an AI assistant who answers like Homer Simpson would. And then the question of the user is, hello, I'm Toon Vanhoutte, how are you? You can provide a max tokens and the temperature. And to make it a little bit funny, I created here a temperature of 1 because that gives a lot of creativity on the large language model. Oh, that's strange. Wow. This got deleted. Okay. This is not the intention. Yeah.
No.
I think my account got locked. My apologies for this. The other demo will definitely work. What I wanted to show here, and that's maybe the most important one, is first of all, I send my first request and I say, hello, I'm Toon, how are you? If I then send a second request to that same large language model, and I will ask, can you spell my name? Then the large language model will not be capable of spelling my name. Why? Because it doesn't remember my first call that I did. It's just a large language model that is being used by many users. So the important thing is it's stateless. So if you wanted to remember the conversation that you had, you actually need to send the history together with it. So that means actually, hey, I have my first system message. Then the user message, hello Toon, how are you doing? This was the answer that I got from the assistant. You see, this is an assistant message. And he said, okay, I'm Homer Simpson AI. What can I do for you, buddy? And then I need to send my next question. Can you spell my name?
Yeah.
In this case, the assistant, Homer Simpson, will be able to spell my name. So that's it's a very simple concept, but many people don't grasp that in the beginning.
Yeah.
You always need to send your full chat history. Otherwise, the large language model forgot your previous call. It's stateless. It doesn't remember anything by default.
Correct.
So that's very important to know.
But this also especially one of the benefits of 4.0, right? It won't be stateless anymore. It will have a memory of previous conversations.
By default, it's still stateless, but because they are using the assistance API, it's actually a layer on top of the large language model. There they keep the state for you. So if you use the chat completion API, it's 100% stateless. If you use the assistant API, Azure OpenAI is taking care of the state for you. You don't need to think about it. So that's the main difference there. Yeah. So my apologies for the demo here not working. The other one will definitely work, but I just removed some resources and accidentally removed the wrong one. So my apologies for that.
It remains technology, right?
Yes, indeed. So this brings us, the next part, of course, because playing around with ChatGPT, that's all fine. But of course, in organizations, they want this functionality, but on their own data, of course. It's nice that you know who was the first minister in Belgium and when Belgium got introduced, let's say. But that's not good in an enterprise context. So in an enterprise context, you want that reasoning capability of ChatGPT and other variations on top of your own data. And how to do that? One of the ways to do that is with retrieval-augmented generation. So what do many people think? We have hundreds of documents. Let's send all our documents to the large language model. Of course, that will not be possible because, these models have limits in tokens. So they cannot process hundreds of documents at the same time. So when a user asks a question, we cannot go directly to the large language model. First, we need to search the relevant data. First, we need to know what document or which documents, it could be multiple documents, can help us to answer the question of the user. That's actually what needs to happen first. So that search, typically, how do we do that? Previously, it was always with keyword search and maybe some optimizations on keyword search, like fuzzy search and these kind of things. But that's typically based on word matching. That's, of course, very good for precision. If you want to search based on a product number, order number, EAN code, you're good to go. But it doesn't have any semantic meaning. It means it doesn't take the context of the sentence. For example, I'll show that in a second. Cloud computing and the weather is cloudy, that's something different. But you know that because of the context. And keyword search is also language specific. So that's very important. Those are some differences, some disadvantages in keyword search. Luckily, there's another way you can do it, and that's actually vector search. Vector search is, again, is an advanced search, which is based on these large language models. So maybe if it's good for you, let's dive a little bit deeper in that. It's actually, vector search is based on the mathematical representation of text. So all the text you have in your organization, your documents, your database descriptions, whatever you have, should be transformed in a mathematical representation. So typically, your texts, you will need to send it to an embedding model. An embedding model is just like an Azure API endpoint who can do OpenAI endpoint that can do it for you. And that embedding model will convert your text into a vector. A vector is a mathematical representation. It's actually an array of numbers, to say it very simple. I will show it in a second how it works. If you do embeddings into with Azure OpenAI, you can use the text embedding ADA02. That's the most popular one. Recently, the embedding tree has been added, and you can there choose between the large and the small one. The large one is higher quality, but you also need more storage to store it. So it's a little bit, again, deciding their cost of the storage versus the performance of your embedding model. What they've done, what they've seen is that they made such models, but then they saw that data that is related to each other is situated together in that space, in that vector space. Here, the vector space is, let's say, visualized as a 3D thingy, where every text that we embedded has its location in that 3D space. And what they've seen is that, man and woman have the same relation, like a king and a queen. And a brother and a sister, they typically have similar relations in that vector space. The same for the time. Are we talking about the current time? Are we talking about the future or the past? Also, that gets, also that is a relationship. And so there are a lot of relationships that they saw. If we do that embedding right, then actually we have a mechanism which says, okay, the closer you are in that vector space, the more related you are with each other. So that's actually the goal. Of course, this is 3D. This is very simple to grasp. Those vector models, they are 1500D, for example. So that means not 3 dimensions, but 1500 dimensions. So that's something that we cannot represent anymore with our minds. But of course, a lot of options, and of course, very fine-grained way to see that data is actually related to that data. They have the same meaning. So how does that vector search then work? If you want to do vector search, you need a vector database. So you have your text, multiple documents that you will have. You need to embed them, and you convert them into a vector representation. So that's just doing one API call, and then the result, you store it in the vector database. Then all your vectors are in a database. That's nothing else than just an array of numbers. And that vector is actually representing the location in that vector space, and that's not 3D, but in that 1500D space where you are. So what I've done, I just visualized here this with a 2D visualization. So your text one will be here somewhere in the vector space and so on. If now the user starts typing a query, they have a question, the user, we also need to convert that user query, which is text in this case, into a vector with the same embedding model that we have on this side, of course. And then we will look, okay, where is that vector? Where is that user query, the vector of that user query in our vector space? And who is the nearest neighbor? Who is the closest vector to our question? Because the closer they are, it means the more similarity have. So the higher the probability, if I have an answer, that's, if I have a question, that the answer will be in that piece of text. In a mathematical way, they do that with cosine similarity. So they calculate the cosine between all the vectors, and they say, okay, if you have a cosine of 1, the closer you get to 1, the more similar those two vectors are. If you have a cosine of almost 0, that means that they don't have anything to do with each other. Of course, the nearest neighbor in America, your nearest neighbor can live 50 kilometers away from you. So it's not because if it's the nearest one that it's still relevant. And so you need to make sure that that cosine gets more and more to the number 1. So in this case, text number 2 will be probably, that document will probably the most likely to contain the answer to the question. That's actually what we want to do. So it's a very difficult concept to grasp, but in the end, it's just using some SDK. You don't need to calculate the cosine yourself. You just call an API, you use an SDK. It's all made very simple for you. I'm not a mathematical expert. I'm not an AI expert, but thanks to this generative AI and these things, I can use it. I'm just a normal developer. So that's the good thing, of course. You don't need to be an expert anymore in that space. If you want to use vector databases in Azure, Azure AI Search is the most popular one. Unfortunately, it's not available yet in SQL Server. And that would be a nice addition because we see a lot of applications are currently already using SQL Server, but it's not natively available. You could do it, you could build it yourself, but it's not optimal there. So that vector search, why would we use that? Because it has that semantic meaning, it has that context, and it's also multi-language. Those are two big advantages of vector search. And with vector search will know that infrastructure as a service is actually the same as cloud computing. They are different words, but because it's trained on a massive amount of data, it just knows, they are quite close, these words in the vector space, that they have the same or at least a similar semantic meaning. And that's very important. In reality, of course, you want to combine both. Sometimes you want a precision search, my apologies. In other kinds of scenarios, you want to have more the semantic search. So let's just combine them. And if you use Azure AI Search, that's what they call hybrid search, where you, under the hood, what will Azure AI Search do for you? It will do a keyword search and it will do a vector search. It will look at the score, the relevance of those data, and it will re-rank them into one result set. That's very powerful. And that way you get the best of both worlds.
Yeah, it's incredible indeed. Yeah, there's so much processing power required for this kind of stuff, and still indeed, if you can deliver the answer so fast, that's.
Well, it's very, very powerful, and it's actually just a way to do advanced search. That's actually
true.
And that's what we see most of these use cases. Okay, we have a lot of Gen AI use cases, but I think 50% of the use cases that we get, questions from customers, can be solved with what I'm explaining right now, with that RAG, retrieval-augmented generation. So I'll come to what it actually means in total, but this is very important. Before we come to that, one more thing, a very important thing, it's about chunking. We have documents, of course, in our organizations, documents or whatever. It could be Excel files, PDFs, Word documents, all over the place in SharePoint, in on-premises file shares, hopefully also a few in Azure. So unstructured data, but these documents can be quite large. If you have a 100-page document and you create a vector of that, what's the point of that vector? Because it will represent the whole document. It's better to chunk your documents and maybe in chapters or alineas, so you have chunks. The data that you chunk is relevant. And of course, these embedding models, they have a token limit. You cannot send a 1,000-page document to that. Most embedding models currently have a token limit of 3,000 tokens. So what do we need to do with our documents? We need to chunk them in smaller pieces that belong together, and every chunk needs to vectorize. So we need to create a vector of each chunk. So it means if you have a 100-page document, it could be that you extract 1,000 vectors out of it, 1,000 chunks, of which you create 1,000 vectors. How do you do that? It's LangChain can help with that. LangChain is a Python library. In an ideal use case, you can split by chapter, because chapters contain the data that belongs together. So if you have documents in Markdown, it's very easy because Markdown is really made with that hierarchical structure, and then you can just split per chapter. Azure has a great service where if you have a PDF and you send it to, it's the Azure Document Intelligence Service, it will return a Markdown for you. And then you can just split your big documents with the Markdown splitter. So that's very nice. Challenges. I think the biggest challenge is that Word documents and PDFs are quite complex. So it's not always easy to deal with them. Definitely, they also contain tables and images, and you also want to take them into account in your large language model. So my experience is that by using that Azure Document Intelligence Service, that a lot of the complexity is again handled by you by Azure. So my recommendation is if you have PDFs, send them to Azure Document Intelligence. You will get a Markdown back, and then you can just split that Markdown into different chunks. And that's the easiest way to handle chunking. So if we bring all these concepts together now, we have the concept of retrieval-augmented generation. To be honest, the first time that I read this, this naming, for me,
What are
I
we talking
did
about?
it very well. But actually, there are three concepts that are being combined. Retrieval is about first retrieving the relevant information from your documents, from your knowledge base, to answer the question. So you get a question, and the first thing you need to do is get the relevant information from your knowledge base. And then you augment the question of the user with that relevant information. So you do first a vector search in your knowledge base. You get a few chunks back that are relevant. And then you send the original question augmented with the chunks to the large language model. And you say, dear large language model, I have a user with this question. Please get the answer from these chunks, from this text. And then the large language model will generate for you a contextually relevant answer. Because of course you instruct the large language model to only base its answer based on the data that you provide. It should not invent any data, or it should forget everything it knows. It should only base its answer based on the input that you provide. And of course, you give additional instructions. Dear large language model, if you don't know it, please be honest. If the information is not relevant, just let it know. And that brings us together with the reference architecture and how these RAG, they call it RAG, retrieval augmented generation systems work. It all starts with your data, of course, and data could be scattered all around. You need to chunk your data if it's unstructured data. So put it in smaller pieces. That's maybe one of the most challenging tasks that you have. Sometimes you need to enrich it. You can use AI for that. Add some metadata to it, for example. And you need to embed it. So you need to create a vector out of it. And those vectors need to be saved in the vector database, typically Azure AI Search if you're in the Microsoft world. So then typically in that vector database, you keep the URL of your documents, because you want to, later on, you want to point to the document where you found the information. The page number is, of course, also handy, because then you can say to the user, okay, hey, I found this answer, and you can find it back in that document at that page. Of course, the text of the chunk should be saved in that database, because we do hybrid search, so the keyword search will be based on that text field.
Yeah.
And we also save the vector representation, that's for the vector search, all right? This can be, this ingestion pipeline, this is a typical integration use case. So again, integration developers, we need them all over the place. This can be run continuously. If your data is continuously evolving and changing, you need to make sure that your vector database is in sync with your data. Sometimes it can be just a one-off script. If we have use cases where we do RAG on top of manuals, user manuals, these manuals, they don't change every day. So then we just have a script who chunks the data, enriches it, and puts it in the vector database. And then we have the application, of course. You always need a user interface. You send the question, and the user has a question. It gets sent to the API. We vectorize this question. So we make a vector representation, and the vector search will get the chunks that are most relevant to this question. These chunks, together with the original question, are sent to the large language model. And based on that information, the large language model will generate an answer, and that answer will be sent to the end user. So that's how RAG works, retrieval augmented generation. So do you want to see maybe a demo of this?
Yeah, of course. Yeah.
Right, yes. So for the demo, we have actually a job matcher copilot that we have built for one of our customers. This is the prototype that I can show you. It's actually to make sure that we find the right job for the candidates, but also the right candidate for a certain job. So it's actually CV matching that we do.
Yeah.
Oh, the CVs, they were stored on SharePoint in this case, in Word and PDF documents. And we had to, of course, follow our reference architecture. So the first thing was chunking. But we looked at all these CVs, and to be honest, the CVs are not that big. It's about one page until maybe 7 pages maximum, something like that.
Yeah.
So we didn't find the need to do chunking over there. So that was already a lot of work that we didn't have to do.
Yeah.
The second thing was enriching. We wanted to get some metadata from the CVs. For example, please give me the name of the person. Give me the number of years that this person worked. Give me the technologies that he or she is proficient in. Give me the soft skills, the roles, the sectors that he or she works in. So give me some metadata extracted, please, from the CV. I can show you how this works. Oh, it's on the other side that I need to go. I have here an API call that I do, that I did, and I asked actually, please, this is the text from a CV, and just extract all the data, and then you see that the data got extracted. And this is a colleague of mine, his name, the years of experience, the languages, the technologies that he works in, the soft skills, the roles, and so on. So this works quite nicely. This is a wrapper API that I've written on top of Azure OpenAI, where I have my system prompt and my user prompts. So this is a slow API call because I'm using here a preview version of GPT-4. This takes, I think, 40 seconds, but it's not that bad because in the end, it's a background process. So the user doesn't have to wait for that. So there we wanted to have the slower, but the better performing model, so with a better accuracy. That's why we've done this one. We will come back later on when it's done.
Yeah.
Then, of course, we had to embed. What did we embed? We need to create vectors. The CV text, so the whole text of the CV, we made a vector out of it. And we made also, we created a summary. Also, that summary gets vectorized. So we have two vectors, one of the whole CV and one of a short summary. And that we store in Azure AI Search. So if we go to Azure AI Search, we will see that over there. So let me see here. This one is still running. It's also because it's a container app. So it has a cold start. So let me first go to my Azure Search solution here. Where I have, let me see here, my index. I see currently in my index, apologies, it's this one that I need to select. I have 32 CVs. It's not a lot. If I do a search on my CVs, you get an array back of all your CVs. So I have here 32 CVs. You see here the file name. So this is the file name. This is the URL of the CV. This is the name that we extracted, the number of years experience, the languages that this person has, the technologies that he or she masters, the soft skills, and so on. All of this is extracted by Azure AI, OpenAI.
Yeah.
We have here also the text of the CV and the text vector. And here you see the text vector. This is just an array of a lot of numbers, floating point numbers. We have also the summary of the CV, and the summary got generated by ChatGPT-4 also. And then we have a vector representation of that summary. And so you see, this is what's inside our database. If we go back here to my API call, it has now completed. You see that this data got extracted, and that it made a nice summary of the whole CV. So this is cool stuff. So this is to extract metadata. You can also use that Gen AI thing. All right. So we've built that pipeline. Our data is now in Azure AI Search. Now we can start building the application. So for the application, we have, of course, the app. The user sends the question. We vectorize the question and do a vector search. We get the most relevant CVs back. And then we say, okay, dear OpenAI, here you have the original question. And we also give them the summary of all the CVs. And then we say, okay, please select the best candidates. And that answer will be shown to the user. And this is a way to easily find the best candidates.
Yeah, indeed. Well, with 32 CVs, well, it can still be done manually, right? But indeed, yeah, if you're talking about hundreds and hundreds of CVs, well, it will be something different.
Yeah, indeed. So of course, this is a limited prototype.
Yeah.
But soon we will start rolling this out on bigger data sets, indeed thousands of CVs.
Yeah.
Then of course the value becomes really, really nice.
Yeah.
What we've done here in this prototype, let me show you a very simple application that we've built. I'm not a front-end guy, so it's very basic.
Oh, we're integrators, right?
But the cool thing is this is an application where you can test already a little bit how the RAG works. So for example, I can say, I am looking for a .NET developer with 5 years experience who could take up the role of Scrum Master. Let's say we have this question. I have here some options. Of course, in a real user interface, you will not give these options to the end user. But of course, this is here to play a little bit with all the settings that we have. So here you can choose, will we do keyword search, vector search, or the hybrid search? Let's keep it on vector right now. How many search results will we send to our large language model? Will we only take the top 3 CVs, or will we get 8 CVs, for example? In this case, let's take 8 CVs, so the large language model can still make its own reasoning on who would be the best person. And then, of course, with GPT, we have also some options. In this case, we use GPT 3.5 Turbo because it's fast and it's cheap. And for most reasoning capabilities, it's sufficient. If you want higher quality, you can, of course, select another one.
Yeah.
So let's do the search. The first thing it does, that was very fast. It did a search on my Azure AI search database. So this was the vector search. And you see, out of the vector search, we got 8 CVs.
Yeah.
And then, based on these CVs, ChatGPT decided that Ben Bora is the best match for this one. And actually, he is, because he is a .NET developer with more than 5 years experience, and who took up in the past already a Scrum Master role. So that's very nice.
Yeah.
The cool thing is, what happens if I now ask for 10 years experience? Because he doesn't have 10 years. I think he has something right, 8 years experience, not 100% sure. If we switch this to 10, you will see that the vector search doesn't take that into account. Because the vector search still selects Ben because, it's still close in the vector space, and it's not because it's 5 or 10 years. But ChatGPT has the reasoning capabilities to read the CV of Ben and sees, okay, this person does not meet the requirements of 10 years, so I will take somebody else.
Yeah.
This doesn't always work perfectly because, it's a large language model. You never know 100% how it will behave. So if you have, for example, a very hard requirement and you say that person needs to live in Belgium, or the person needs to have at least 10 years experience, you need to combine it with traditional search. What I can do is combine here with traditional search and say, okay, I will say at least 10 years of experience. If you then do a search, we will not have Ben anymore in our search results, because we did with traditional search, we limited the AI search on the CVs who had at least 10 years experience.
Yeah.
So that's an important thing for me. It's not only about ChatGPT only, because nowadays, people, they want to do everything with the chat application. I'm convinced that we need to combine, definitely for RAG solutions, traditional search together with that large language models, and combining those two is more powerful. You get more control, and sometimes you have hard requirements. Then maybe it's better to do it with traditional search.
Yeah, that's a thing indeed. Yeah. Itself indeed. Well, the question that you had indeed about the person you are looking for, it is very useful to just do it in free text, right? That really makes it easy. So you don't need to develop forms with all the different criteria. But just like you said, indeed, if there is a hard requirement, it won't be picked up by the question there, right? So
Yeah, not always, because you never know 100% how the large language model will behave. You can tune it, of course. You can make your prompts as good as possible. So if you can do it with some traditional search, definitely do that combination. So
yeah.
So actually, that brings me a little bit to the conclusion, a little bit also the lessons learned, because for me this was also new 1 year ago. And the first one is, get out of your comfort zone. It's we hear about AI, and AI, it used to be that complex machine learning stuff and these kind of things. Yeah, with generative AI, at least a part of AI became very easy to use. So we don't need to be machine learning experts. Of course, we still need them for these more advanced use cases. But it got so much democratized, this generative AI, that actually every developer who could use an SDK and who can call an API can get started with it. It's only one API call away. That's one lesson learned. The second one is more difficult to deal with. It's non-deterministic. It means you never know what comes out of it. If I write my own algorithm, I know it will return a 1 or a 0, but it will always work. If I run it 20 times or 100 times or 1,000 times, I wrote the algorithm, it will also always work. You lose that kind of control with large language models. You tune it as much as possible. You ask it, please, please, please answer in this way. Be polite. Don't talk about the other parties may be involved, but you're 100% sure. So as a developer, I'm a kind of a trick person. It's 1 or 0. It's not something in between. Yeah, that's difficult to deal with.
Gray doesn't exist. Black or white.
Indeed, yes, indeed. And it evolves very rapidly, which also means that you need to update your applications, because a certain version of a model will typically only be supported by Microsoft and OpenAI for 2 years, something like that, 1.5 year, 2 year. So if you want to make sure that your application keeps on working, you need to evolve and you need to migrate to later versions of ChatGPT, for example. But there you have a challenge. Your prompts that worked perfectly for GPT-4 will not work perfectly anymore for GPT-4 Turbo, for example. So you need to reiterate over that. So if you have a big project, it might be good to invest in some automation over there. They call that prompt flow, some automation to make sure that you can validate your prompts.
Yeah.
And then the last one, it's about user experience. I'm not a true believer of pure chat-based interfaces. Personally, I don't think it's that productive. So I think it will be a combination of chat-based with other old school facets, UI elements that we have.
Yeah.
So the user experience will be very important to make sure that we get the maximum speed and the maximum efficiency in the challenge that we want to solve for the customer. So user experience, it's all about the UI, the UX, how many clicks, how many typing do I need to do to get my final end result. So I'm convinced that it's a combination of chat-based interface and old school web interface. So.
Yeah, very clear.
And maybe that's I have a background of integration, and what I just see is that every generative AI projects that we've done out there needs integration. It's always getting the data in your vector database. It's calling external APIs, because now it was only on static data. But of course, in the future, you want to maybe also get live data from your SAP instance to know the prices, for example. Yeah, that's just, again, an integration. That's an API that you need to expose to the application. So in the end, these Gen AI projects, they are sitting between different applications and they want to search and get data from different applications. So in the core, a lot of these applications, projects are integration projects. So that's very good. And for me, integration developers are a little bit the Swiss knife of the whole IT world. So that's why I think it's important that these people definitely invest in generative AI and start playing with it.
Yeah. No, yeah, that totally makes sense, right? Yeah. In the end, well, yeah, to put it real flat, it's just a smart way, to be able to access your data. And of course, there's much more to it, but in the end, that's what always is happening. Yeah.
Of course, this graph that I showed now is only one part how you can use generative AI. It's mostly to find back the right document and the right data. That's often it's actually an advanced search. So this is a request that we often get. Of course, there are a lot of different applications of generative AI. I could talk hours about it, but I think this is the most basic Gen AI setup. So definitely worth checking it out.
Yeah. No, that's great. Thanks, Toon. Very, very interesting session. That's for sure.
Welcome.
Yeah, so I think let's wrap up this one. I enjoyed it a lot. I hope you, the audience, also loved it a lot. Thanks for being with us again. Toon, thanks again, and we will see you in the next one.